From the last video, I started talking about algebraic expressions with sorts, and we saw how we could simplify expressions involving sorts where we use identities like a minus root b all squared, and we have a very simple way of expanding that to be a squared minus 2 minus 2a root b plus b, like that. So you have for a minus root b all squared, a plus root b all squared, and things like that. And I also tried to talk about some algebraic identities that can be carried over into the concept of sorts. So still talking about algebraic expressions with sorts. In this video, we'll talk about rationalizing complex algebraic fractions with sorts. Okay, so we move on to talk about that now. So rationalizing complex algebraic fractions with sorts is what we are looking at here. This lesson explains how to simplify complex algebraic fractions that contain surds. We will study three main topics: fractions within fractions, multi-step rationalization, simplifying fully. The main goal of rationalization is to remove surds from the denominator. We've seen that, in the next in the videos we've been considering lately. So a final answer should always have a rational denominator. So when you rationalize, is when you do rationalization, you are removing radicals, sorts, roots, from the denominator, so that you then end up having a rational number or so in the denominator. So here we are dealing with rationalizing complex algebraic fractions with sorts. So straight up, we go to talk about fractions within fractions, like you have some complex fractions like that. So a complex fraction is a fraction where the numerator or denominator contains another fraction. Example, you have 3 over root 5 all divided by 2. So the method to handle this is to simplify complex fractions. You rewrite division as multiplication, then you multiply by the reciprocal, and then you simplify and then rationalize the denominator if necessary. So it's like you're putting many things together. So here, imagine that first example, you have 3 over root 5 all over 2. So first you rewrite as multiplication. So this can be written as 3 over root 5. So this is like okay. So this is like 3, this is 3 over root 5 times 1 over 2. Okay, so you then have 3 times 1, 3, root 5 times 2, that's 2 root 5. Then you rationalize the denominator. So now, with after that one step, you can already see you need to rationalize, and it is just one sort at the denominator in the denominator. So rationalize the denominator, multiply top and bottom by root 5. So you have 3 over 2 root 5 times root 5 over root 5. So that's 3 root 5 over 3. 2 times root 5 squared, that's 2 times 5, which is 10. So you have 3 root 5 over 10. So then example 2. So you have 5 over 3 divided by 2 over 3. 5 over root 3 rather divided by 2 over root 3. So you multiply the reciprocal. So you have 5 over root 3 times root 3 over 2. You can cross, you can, yeah, that can actually cross out, right? That I think it's better to just cross it out straight. And the answer is just 5 over 2 without hesitating. But if you just want to if you want to be finicky, you can say that's 5 over root 3. 5 root 3 over root 2 root 3. So root 3 cancels out. And the answer is 5 over 2 at the end of the day, or 2.5. So we can also have multi-step rationalization. So sometimes rationalizing requires more than one step. This usually happens when the denominator contains two terms. Example, you have a plus root b. So to remove the sort, you multiply by the conjugate. So the conjugates will be a plus root b with its conjugate a minus root b. So if you square that, like we've seen already in the last video, that ends up giving us a squared minus b. So the sort disappears because of the difference of squares. So example 3, talking about that now, will be something like this. You have 2 over 3 plus root 5 multiplied by the conjugate. So you have 2 over 3 plus root 5. The conjugate of 3 plus root 5 is 3 minus root 5. So you have to say 3 minus root 5 over 3 minus root 5. This is as good as 1. So if you multiply something by 1, it doesn't change. The form changes, but the essence doesn't change. So you have 2 into 3 minus root 5 all over 3 plus root 5 into 3 minus root 5. So you have all this. Then you tidy things up. You have 2 times 3 minus root 5. That would be 6 minus 2 root 5. 2 times 3 is 6. 2 times root 5, you have 2 root 5. Then for the denominator, difference of squares now, 3 plus root 5 into 3 minus 5. That's 3 squared minus root 5 squared. That's 9 minus 5, which is 4. So you end up having 6 minus 2 root 5 over 4. So you can factor out 2 here. So you have 2 into 3 minus root 5 all over 4. So 2 cancels 2, 2 goes in 4 twice, and you have this expression. So the final answer is 3 minus root 5 all over 2. Then we talk about rationalizing algebraic fractions with surds, rationalizing algebraic fractions with surds now. So you have some algebra coming into this that involving things like x here. Now we include variables. So example, you have 5x over root 7 multiplied by root 7, right? So you have 5x root 7 times root 7 over root 7. So you have 5x root 7 all over 7, and that is your final answer right there. Then you can also have multi-layer. You can have multi-layer complex fractions. Sometimes the entire denominator is a fraction. So you have 1 over 1 all over 2 all over root 3, right? So multiply the reciprocal. So you have 1 divided by 2 over root 3. That means 1 times root 3 over 2, and then that's root 3 over 2. Well, this one is already in the proper form, in the form we like to have it. There's no surd in the denominator. So the reason why we rationalize is we have a problem with surd in the denominator, but if you have surd in the numerator, no problem, right? So we can look at some complex situations still. So complex example, a full process. So you have 4 over root 2 divided by 3 plus root 2. So you can write as multiplication. This is 4 over square root of 2 divided by 3 plus root 2. So that means 4 over root 2 times 1 over 3 plus root 2. Then 4 times 1 is 4. Then root 2 into 3 plus root 2. And that means you have to keep going, right? So that's 4 now. To rationalize, so you have to keep rationalize. So to remove these two first of all, so you have to take care of this first. So you have 4 times, so you multiply top and bottom by root 2. So you have 4 over root 2 into 3 plus root 2. You have root 2 all over root 2. So to take care of this root 2 now, you have 4 root 2. Root 2 times root 2, that's 2. So that 2 now multiplies 3 plus root 2. And what do you do? 2 goes here, 2 goes here, 2 goes here 2 times. So you have 2 root 2 all over. This 2 is gone then. So you have 2 root 2 into 3 plus root 2. Then now you have an expression that is binomial. That means you have 3 plus root 2. So you now need to multiply. In the first case, to take care of root 2, you needed to use root 2 over root 2. But now you want to take care of you want to take care of um, a binomial term. So in that case, you then use the conjugate. So if you have 3 plus root 2, the conjugate is actually 3 minus root 2. So you multiply the top and the bottom by 3 minus root 2 so that it's as good as you're multiplying by 1. And then you keep on with that to get the desired result like that, as I'm going to show just in a moment. Okay. Yes. So we have 2 root 2 plus 3 minus root 2 over 3 minus root 2. 2 root 2 over 3 plus root 2 like this. So 2 root 2 times 3. 2 root 2 into 3 minus root 2 all over difference of squares now. So you have 3 squared minus root 2 squared. That's 9 minus 2, which is 7. So for this now, you have 2 root 2 times 3, that's 6 root 2. Then 2 root 2 times root 2, that's 2 root 4, which is 2 times 2, 4. So you have 6 root 2 minus 4 all over 7. And that is the final answer there. So simplifying fully now, to simplify fully, after rationalizing, always check that you cancel common factors, simplify sorts, expand brackets if necessary, combine like terms, ensure the denominator is rational. And of course, we see this in example 7. You have 3 over 2 root 8. So make sure you simplify this 8 now. So root 8 is 2 root 2 because root 8 is root 4 times 2. And root 4 is 2. You have your root 2. So it means 3 over 2 root 8 is like 2 times 2 root 2. That's 4 root 2. So you have 3 over 4 root 2. And then if you rationalize that now, root 2 is the issue there. This root 2. So you have 3 over 4 root 2 times root 2 over root 2. That's 3 root 2 over 4 root 4, which is 4 times 2, 8. So you have 3 root 2 over 8 as what you have in that situation. So what is a strategy checklist when you're working with this kind of when you have this when you are rationalizing complex fractions like this? So strategy checklist: when rationalizing complex algebraic fractions, step one, remove fractions within fractions. simplify the expression, rationalize single surd denominators, rationalize binomial denominators using conjugates, and simplify completely. So in this case, now it feels like everything we've been learning about rationalization now comes together, so we can have a serious showdown all the time. So you have this practice problems. Let me show them in fives. Yeah. So simplify each expression fully and rationalize all denominators. So 3 over root 2, of course, we know this will be 3 root 2 over 2. 5 over root 7, that's 5 root 7 over 7. 4 over root 3, that's 4 root 3 over 3. 6 over root 5 is 6 root 5 over 5. Then, of course, here we have 7 over 2, 7 over 2 root 3 times root 3 over root 3, that's 7 root 3 over 6, like that. So let me see which one I should do here. Let me go for the last one, 6 over 3 plus root 7, right? 6 over 3 plus root 7. So we have 6. Uh, how come I forgotten just now? 6 over 3 plus root 7. Okay, that's still fine. 6 over 3 plus root 7. So you have a binomial term here, so you need to use conjugate. So that will be 6 over 3 plus root 7 times 3 minus root 7 all over 3 minus root 7. Okay, so that will be 6 into 3 minus root 7 all over 3 plus root 7 into 3 minus root 7. So that you then have 6 times 3, 18, minus 6 root 7 all over, you have 3 squared minus root 7 squared. So that is 18 minus 6 root 7 all over 3 squared is 9. Root 7 squared is 7, like that. So you have 18 minus 6 root 7 all over 2. Okay, so here 2 is common. So we have 2 into 9 minus 3 root 7 all over 2. So 2 cancels 2 here. Okay, 2 cancels 2. So we then have that to be 9 minus 3 root 7. Then I always, for me, I always like to be sure I got the whole thing right. So I always want to double check to be sure. So 6 over 3 plus root 7. Okay, so I'll come to decimals. 6 divided by 3 plus square root 7. That gives us 1.06 something something. Then we come back here and check the last thing we got to be 9 minus 3 root 7. So that's 9 minus 3 square root of 7. So exactly the same thing. So we are good to go. So that's question 10. From 11 to 20, we have the fraction issues. So let me see the craziest of them all. Yeah, let me just go for 20. Uh, so this time around, I have 6 over root 5 all over 2 plus root 5. 6 over root 5 all over 2 plus root 5. Okay. Um, 6 over root 5 all over 2 plus root 5. So we need to tidy this. So we have a fraction in fraction like this. So this is 6 over root 5 divided by 2 plus root 5. Okay. So you can see that as 2 plus root 5 over 1. So that means you have 6 over root 5 times 1 all over 2 plus root 5. Okay. So that this now becomes 6 times 1, 6 all over root 5 into 2 plus root 5. So here we are going to have this in layers. We can get rid of this root 5 first, being a single surd. So we have over 6 over root 5 into 2 plus root 5 multiplied by root 5 all over root 5. Okay, so that will be 6 times 5 root 5, that's 6 root 5 all over root 5 times root 5, that's 5 into 2 plus root 5. So yeah, 2 plus root 5 like this. So we then have mm, so we can then multiply by this 2 plus root 5 now, you know. The conjugate, because it is a binomial expression. So we have 6 root 5 all over 5 into 2 plus root 5 times 2 minus root 5 all over 2 minus root 5. So with this now, we then have, we have 6 root 5 into 2 minus root 5 all over 5 into 2 plus root 5 into 2 minus root 5 like this. So we tidy things up. 6 root 5 over times 2, that's 12 root 5 minus 6 root 5 again. All right. So yeah, I think that's looking like a good thing. 6 root 5 times 2, that's 12 root 5. 6 root 5 times, okay, so 6 root 5 times root 5, that's 6 times 5, that's root 25. That's 6 times 5 all over here. Now we have 5 into 2 squared minus root 5 squared. That's doing this together. That's 2 squared minus 5 squared. So we then have 12 root 5 minus 6 times 5 is 30. Okay? 6 times 5 is 30 all over 5 into 2 squared is 4 minus root 5 squared is 5. So we have 12 root 5 minus 30 all over 5 into 4 minus 5, that's minus 1. So we have 12 root 5 minus 30 all over minus 5. So we then have, I mean, the 5 can go, if the 5 goes up, we can say we have 30 minus 12 root 5 all over 5. So the minus can flip the top over, and then we can have it this way, okay? So, but then thankfully we have a way to check if what we have done is right, okay? So we then have what we started with. Oh, this is a big one. So we have 6 over root 5, right? We have 6 over root 5 all over 2 plus root 5. So we can still check 6 over root 5. So here now we have, this is 6 divided by square root of 5. All of this again divided by, what's that now? 2 plus root 5, I believe. Yeah, 2 plus root 5. So that's 2 plus square root of 5. So we have that. So what did we end up getting? We ended up getting um that last result, 30 minus 12 root 5 over 5. 30 minus 12 root 5. So 30 minus 12 square root of 5 all over 5. So exactly the same thing. So we are good to go. So that's actually correct. So we are good. So yeah, with this, we come to the end of this interesting video on working with algebraic expressions with sorts. So don't forget to try your hands on, all these questions to be sure that you actually have a good grasp of everything I've been explaining. Don't forget that you can also, after doing each question, you can also check to be sure that you have done the right thing, okay? So that can help you to understand if everything is in order. So you can check your calculator to be sure, to check what you started with and what you ended up getting, so you can be sure the answer is right or not. On this note, I come to the end of this interesting video about rationalizing complex expressions, complex fractional expression, complex. Let me be sure of that. That's rationalizing complex algebraic fractions with sorts, exactly. So you want to try your hands on this and be sure you have a very good hang of that. Yeah, so ultimately, don't forget to comment, like, and share this video so that more people can have access to the great content I have going on here. If you have subscribed already, I thank you very much for doing that. If you haven't subscribed, why not go ahead and subscribe right away and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of the channel by clicking on join. That gives you special privilege that I get to see some videos first, and or some videos can be exclusively made for you as a member of the channel. Okay. Again, don't forget to comment, like, share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.